Welcome to the AI Standard Stack with me, Michael Mainelli, Director at Zien Group.
And me, Adam Smith, Chair of the AIQI Consortium.
Each episode on AI Standards Stack, we discuss developments in AI assurance with guests from around the world that are leading the charge on the standards, ethics, and regulation of AI.
On the show today, we're joined by Nicolas Cubaud, founder and CEO of iSnap and co-founder of TotalYmage with a Y, not an I. He serves as the editor of a European harmonized standard, which is a preliminary European norm, 18281, artificial intelligence, evaluation methods for accurate computer vision systems. The standard is developed under Sensenelec JTC 21 in support of the EU's AI Act. With over 25 years of experience in computer vision and image processing, Nicola leads this project to support compliance for AI-powered computer vision systems.
Well, welcome to the show, Nicola. It's a pleasure to have you on. And before we unpack the stack, I was wondering, might you like to say a few words about your professional background, particularly the work in computer vision and iSnap? And we'll get on to TotalYmage, I think, later.
Yes, well, first of all, thank you for inviting me today. I'm very pleased to be with you. Regarding basically the work we do at iSnap on the TotalYmage, we have kind of followed, let's say, the same objective for for a few decades now. It's really to help industrial companies and field workers, in their daily activities to turn an image or a video, into an actionable, let's say, business information. Okay. Everybody knows how to take a picture, how to make a video. So we are really trying to leverage, let's say, this source of information to help businesses. So just to give you an example, we, for instance, help people in the nuclear industry, to go much faster, into their conformity assessment, just by taking a 1 minute video of a working area with a tablet, it basically divides by 6 the time of, use for control. So it's an example on how like a video, can be turned into like let's say a conformity report, to validate, let's say, all the regulatory equipments that are needed on the working area. It can be also to check if workers on site, especially regulated sites, wear proper equipment like helmets, etc., to make sure that they are safe. And, when they enter an hazardous area, make sure that they are well equipped, to be working in safe conditions. So that's kind of examples. There are many of them, but some examples that of projects that we do for our customers. Okay. And now maybe just to give a little bit more background on information about the let's say the standard, the prEN 18281 that we've been working on. I just want to say that it has been a very collective work. I'm here today. I'm very happy to be with you as the editor of the standard, but we have been really working as a team with other colleagues from France, from Denmark, Austria, Hungary, that we are also all new to standardization. So, it has been a great learning experience. Like every day we keep learning on standards, and also through help of people like Adam, who are very experienced. So yeah, so that's basically my background in computer vision and also in the standardization edition.
Well, thank you for that. It's a good opening there, Nicola. We're going to cover a lot of acronyms today, and I just thought I'd help out a little bit by setting a few out up front. So we're talking about Senelec. Sen is the European Committee for Standardization, naturally being French and deferring here, that's CEN. And then we have Senelec, CENELEC, which is the European Committee for Technical Standardization. And then you referred quite rightly to prEN 18281. Sometimes I think we should be reading these things out rather than trying to do it as a podcast. But that, of course, is a very, very important European standard, really directed at computer vision. So I just lay that out for the audience. Senelec and prEN 18281 on artificial intelligence evaluation methods for accurate computer vision systems. So you've had an exciting career in computer vision, 25 years, founding iSnap and TotalYmage. Why did you think that standards were an area that you wanted to devote some time to?
Well, it was, let's say, quite an opportunity. I mean, I didn't really look for it, but since we work a lot in the industry, especially in the, let's say, regulated industry, like for instance, I mentioned the nuclear industry. It's not the only one. But I was thinking, well, I know that the AI Act is under discussion. Of course, there's going to be an impact, for us as a solution computer vision solution providers, also for our customers, who are going to deploy, computer vision systems in this regulated environment. So basically, it was about a little bit more than 3 years ago. I wanted to know more about this AI Act, like how it would impact our customers on us. And I attended a conference that was led in Paris by Patrick Beson, who is the co-chair of the GTC 21. And we had a good discussion, and he told me that there was basically a gap, for computer vision systems. There were a standard that was ongoing, for the NLP, but not for computer vision systems. So if I was interested in the topic, I could basically be leading this initiative. So I was probably a little bit crazy, but I said yes. And actually, it has been a very, very interesting, very exciting journey. For me, the goal was really to try to help, let's say, companies at a wide scale, to develop like AI-based computer vision system in a very trustworthy manner. Okay, so I thought it was a great opportunity to jump into this new standardization experience, basically.
Well, in preparation for this, I thought I would consult an expert, and I have an article I want to read just 2 quick paragraphs from. Computer vision is everywhere in high-risk AI. It sits at the heart of medical imaging diagnostics, autonomous vehicle perception, industrial quality control, biometric identification, and workplace safety monitoring. Almost every sector covered by the EU AI Act's Annex 3 risk categories involves a system that at some level processes images or videos and makes decisions. Yet until now, there has been no harmonized European or international framework, for that matter, on how you actually measure whether a computer vision system is accurate. Providers have been left to pick their own metrics, apply them inconsistently, and present results that are incomparable across implementations. For conformity assessment purposes, this is a problem that needs to be solved. It's one A.L. Smith, can't work out what his name is, who wrote that. Anyway, I think it is important for our audience to grasp how fundamental this is. So your standard, prEN 18281, just entered public inquiry under the CEN-CENELEC JTC 21. Could you walk us through what does the standard cover and why having solid evaluation methods matters so much?
Yeah, well, thank you, Michael, for putting the context around the standard. So yeah, that's basically the standard regarding the evaluation methods. Okay, so the prEN 18281 is really dedicated to support the methods, for let's say selecting, applying, and interpreting evaluation of computer vision systems. Okay, so it includes quantitative metrics and also like technical evaluation methods. Okay, like we basically develop like 2 standards. So the one for the evaluation methods and also another one that's related to taxonomy, like the taxonomy of computer vision tasks, because as you pointed, it's very important to speak, let's say, a common language. Okay, so basically, like as you mentioned, computer vision, it covers a very vast number of use cases. Okay, It can be detecting pedestrians crossing in front of a non-autonomous vehicle. It can be generating images with DALL-E or Midjourney. There are many computer vision tasks, and it's true that there was a gap, to basically describe, have a common language, for this computer vision task, for like classification, detection, segmentation, tracking, pose estimation, image generation, like all these different type of tasks. So basically, the way we did it is, to develop like these two standards. So one for the taxonomy, and the other one, let's say, they both work hand by hand, for the evaluation methods, for these tasks. Okay. So basically, for the first standard regarding the computer vision task, which is the prEN 18288. We describe the various categories of computer vision tasks, for image analysis, video analysis, image generation, video generation. We describe the task in a simple manner so everybody can understand what it is and make sure that we are talking about the same task, when we want to compare two computer vision systems. And we also describe their input-output. So, basically having a standardized way, to describe this task. And after, the evaluation methods, standard, which is let's say, the core of the focus of our discussion today, is really going to apply, the evaluation methods that will correspond to a given task. Okay. So basically, the goal is really to evaluate these computer vision tasks, to ensure they fit their intended purpose. Okay. And basically, our goal is really to answer the question like how to turn, let's say, a general legal requirement that fits, into the AI Act into something that's technically measurable, reproducible, and also auditable. Okay, so that's really the goal of this standard. So basically, in the 18281 standard, we describe all the metrics that are available, to evaluate the task. Some also come from other standards. There are already standards, let's say, for classification, for instance. Okay, so we are not going to reinvent the wheel. We are just going to use these well-described metrics, and apply them for the specific cases of computer vision. And after, there are also some specific metrics that are, let's say, that are really specific to computer vision. For instance, IOU, intersection over union, for instance, to evaluate, let's say, the capability of a system, to well detect objects, for instance, in an image. Or, there are also metrics for image generation, so that are also very specific to computer vision. So basically, our goal is really to apply, the right metrics in a standardized way, with a common language, to make sure that we can basically compare apples and apples when we benchmark two computer vision systems.
We spoke to Michael Thieme recently, who's the editor of ISO IEC 4213 on this podcast, and that's a similar standard in that you just mentioned it there without mentioning the number, Nicolas, but that they're establishing the same thing for classification, regression, recommendations, and clustering. There's another project which is focused on natural language processing tasks, and we kind of thought that was the full set a couple of years ago, but there's some initial discussions happening recently in international standards about embodied AI, and whether we need a similar standard that looks at the different tasks that robots will essentially perform, planning how to fetch an object and such things, which is quite interesting as well.
Right. Yeah. Thank you, Adam, for the add-on. And after, maybe to answer your second point, Michael, like, why is it important, let's say, to have like let's say, a proper and solid evaluation method in the context of the AI Act, first, let's say it's always the same. Like we start with a problem, that we want to solve. Okay, so computer vision tasks, they can solve certain problems, for detection, classification of objects, etc. And the reality is that there is not, let's say, one fit all metrics, to evaluate the tasks that are used in all the problems. Okay, so basically, if you take the AI Act, it states that let's say a computer vision system, I mean, it's not only computer vision, but it's also valid for computer vision. It requires an appropriate level of accuracy, robustness, and also cybersecurity throughout all the life cycle of the system. Okay, so it means that basically. I mean, the AI Act tells us that an high-risk AI system, must be designed, developed in a way that they achieve this proper level of accuracy, robustness on the cybersecurity. So in practice, it means that we need to have, let's say, valid and robust evaluation methods, to fit this requirement of the AI Act. So basically, when you work in the computer vision field, saying that my system is 95% accurate, for instance, it doesn't mean much, if you don't understand exactly the context, what is measured, on what type of data, under which operating conditions. So basically, first we need to be able to categorize, the type of problem that we want to solve. Is it image classification, object detection, etc., or object tracking? For instance, if you want to follow like an individual in a crowd, for instance, you want to understand if your system is going to be working at day, at night, both. If they are like, if sometimes some false positives, or false negatives, can be very damageable. For instance, in medical imaging, if you miss, for instance, if an AI system that's designed to predict, cancer lesions, for instance, if you miss suspicion lesions in a radiology image, it might be much more impactful for a patient, than missing, let's say, that flagging correctly a benign, harmless region, on the image. So basically, it's very, very important to understand the context on the operating domain of your system. And, like all the examples, shows that when you talk about evaluation of a system, it's usually rather complex. You cannot limit it to, let's say, one metrics on one average score. You need to basically evaluate the system under different conditions with, certain, setting certain thresholds, because again, the consequence of missing, for instance, an object, and I'm thinking again about medical imaging, can be very critical. So it's all these, let's say, things that you need to have in mind, and that basically justify that we need to have a robust method, and yes, and it has to be, let's say, very well defined, to make sure that again these systems are evaluated in a very robust manner.
Well, indeed. And if I can share sort of a personal anecdote, 49 years ago, I entered the Harvard laboratory for computer graphics and spatial analysis. So it's, almost a half a century ago. And what your standard is addressing is so important. So out there in the audience, just think about, how do you detect an object reliably? Does my system detect objects that your system detects? How do we track it? What does it mean? What is tracking accuracy? What is the segmentation of the object? Is that a person, or is that a person with arms or a head, etc.? Depth estimation, 3D reconstruction. There are many, many areas of this standard which are really important, because until you define these, you can't start to evaluate things. So
Right.
I'm going to come back to another question in a minute, but before I do so, Nicolas, your work is firmly rooted in the European AI framework and JTC 21. How do you see these computer vision standards lining up with what's happening internationally at ISO IEC? Are there any tensions there, any conflicts, or is your work supporting theirs, or the other way around?
Well, um, from what I see, I think there is let's say a strong logic of alignment, let's say, between the European and the international levels. Okay, look, like ISO, IEC. The only, I mean, what I would say is that the difference is that the European context is a little bit different, and adds something important is that the standards, are, let's say, being developed like to be bound, to the legal framework of the AI Act. Okay, so it's not only guidelines, but it's like, let's say, legally binding. Okay. So that changes a little bit the role of the standard. I'm thinking about, related to computer vision, for instance, regarding like biometric identification, for instance. If you think about, let's say, in a technical perspective, the metrics, to evaluate these systems, technical metrics, they can be totally similar, whether you are in China or in Europe, we are talking about the same technical systems. But in Europe, and that's one of the goals of the AI Act, it's really to let's say, to put an emphasis, on the fundamental rights, and make sure that these biometric systems, like if you want to follow, for instance, people, let's say for crowd surveillance, this type of use cases that use computer vision, they need to be let's say need to be deployed, they need to be compliant, with the jurisdiction, and basically, and that can vary, depending on the area of the work. What can be permitted in China, for let's say crowd surveillance, is actually not permitted, in Europe, for instance, under the AI Act. Okay. So I would say that, let's say at the international level, there are a lot of standards, AI standards, that have, let's say, being developed, to cover like all the risk management, the data quality, like many different topics. So it gives like a very good background on foundation. And again, the goal is not at the European level, to reinvent the wheel, like everything that's good, internationally, and that fits, let's say, the purpose of the AI Act, of course, we need to use them. But for what is, let's say, specific to Europe, then of course we need to have like let's say our own specific rules. Okay. So basically, to let's say for computer vision, for instance, let's say we also need to make sure, like for high risk systems, that the solutions are well documented, that they are traceable, that there are also like quite a lot of requirements that are requested by the AI Act that we need to fulfill. So I would say, like basically, maybe I wouldn't talk in terms of really tensions, even if they are like little, tensions, because, we need to provide these standards quickly, because, the AI Act is already enforced, so we know that these technical standards to explain how basically we should be compliant with the AI Act, they need to be produced rapidly. So of course there's a tension regarding speed, there's a tension, regarding policy sensitivity. So that's the example, for instance, of biometrics, or crowd surveillance, but I think it would be, let's say, more like we could see it as a layered system, like basically having the international standards, providing the foundation. And in Europe, we will build, let's say, some bricks, on top of that for our specific European needs, actually.
I think this is an example of a standard that should have been an ISO standard. I tried a number of times to get collaboration going between the committees, and for lots of different reasons failed to get the committees to agree to a model to work together. But we have worked together on other things like the equivalent for natural language processing, and that's gone very well. I see a future for this standard being progressed as an ISO IEC standard, as a second version or something like that, I hope.
Right. It's true that for the moment it's let's say SEN lead standard. Okay, so the parallel development with ISO IEC has been rejected. Okay, but it is true. I fully agree with you, Adam. It should be it should move to ISO standard. Yeah.
I mean, one of the things that's on my mind, of course, is we've got the the EU framework, we've got the ISO framework, but we've also got a bit of fragmentation between Europe, the US, China, and frankly some others as well. Do you think that in this particular space we'll eventually land on a harmonized evaluation method, some type of global benchmark, or do you think we just have to kind of tolerate a variety of competing standards?
Well, that's a good and tough question. My take on that is that I think I see harmonized evaluation methods, as, let's say, a global benchmark. Okay, because again, like the standard that we are developing is very technical on wherever you are. The technical problems, evaluation metrics, etc., should remain the same. So basically, I totally agree with Adam's previous comment. I think it should be basically global. But again, after there are specificities that are related to jurisdictions. That make me feel that that will be probably very difficult. To have let's say a global, let's say, bench. Let's say a global standard, worldwide, because of these specific jurisdictions. Now, so I know that we took the example of facial recognition in China, okay, but we see that it's also regulated. Okay, it's more and more regulated. There are specific rules, but it's just that let's say the deployment is being used on let's say it provides some value, for the Chinese people. So I would say that the metric, should be on the benchmark, should be global, but basically the permission to deploy these systems, is probably not going to be. That would be my take, but again, it's a tough question. So.
I think we can agree on the metrics and the requirements for how you apply those metrics to make them repeatable and reproducible. I hope we can all agree on those globally. But if you look at like the accuracy evaluation requirements in the European laws, you're looking at the accuracy in the context of intended purpose and the risk to health, safety, and fundamental rights. And there are many jurisdictions, most jurisdictions do not require an AI system to have a specific intended purpose. They're allowed to be these general purpose systems. And most jurisdictions don't consider human rights in the same way that the European law does. So I think the metrics, we can agree, we can standardize globally. The way you decide whether the results are good enough, I think we are some way away from reaching any kind of harmonization.
Yes, fully agree, Adam.
I mean, do you guys think, in all honesty, if we look at some of the things that we're trying to achieve with this, we've got all the kind of technical accuracy stuff. We've also kind of got robustness and tolerance issues. But ultimately, doesn't this fall into trustworthiness? Does this establish appropriate reliance? Can you give us a few words, Nicolas, on your thoughts on how this is working or not working towards trustworthiness, particularly given Annex 3?
Right. I think it's a very good point because, we have, let's say, many customers using our systems, on basically gaining the trust of a customer. Of course, we expect that our system work well, let's say, for the problem that we need to solve with them is not an easy task. Okay, so basically building trust on making sure that let's say our systems are trustworthy. It's a very delicate and very important mission, let's say. And for me, the AI Act, the harmonized standards, they give us really like let's say guidelines on the great framework, to basically build this trust, with our clients, and it's. So I think, yeah, it's very important, let's say, to connect, to the trustworthiness, which is really for me the condition for adoption. Okay, like basically, if you don't trust, this type of systems, and Adam mentioned how important it is to have also reproducible behaviors and results, for a given intended purpose. If you don't provide that to your customers, of course, they are not going to trust your solutions. It's not going to basically help their process being improved, and basically we lose all the value that we can provide. So I think trustworthiness is really key for adoption. And again, we build the trust. It's basically a two-way. Let's say two-way work with our customers. They have the knowledge, the expertise, like whatever in the nuclear field, etc. We adapt our computer vision AI systems, for their need. And together, we are able to build this trust. And I think the framework provided by the AI Act, is a really, really great tool to make sure that we provide like a transparent evaluation, that we have the right method, to evaluate the system, that we basically have like a relevant testing set, to test the systems in different conditions. And all that basically contribute to trust and the confidence that our customers, can have in our system. So very important.
Well, I'm used to going home and trying to explain to my spouse that that I've had a very interesting AI standards stack podcast discussion, and this is no exception. And whilst she's slowly coming around to believing me, sadly, we are running to the end of time, believe it or not. So, if I could close with a question, because Nicolas, you're extremely interesting to me as somebody who is very technical, but also a genuine entrepreneur, having built up 2 businesses in computer vision. So wearing both your entrepreneur hats, but also the fact that you really are deep into standards and editing of standards, what's the practical advice for companies building computer vision systems today? The AI Act is starting to bite. I'm a, young postdoc coming out wanting to deploy my techniques in computer vision. Why do I want to do anything with standards? What should I actually be doing with this space? Ignoring it, piling in like you do, and volunteering lots of time? Should I just be slavishly following it and paying lots of advisors? What should I actually do?
Well, I think maybe my first advice would be to not to wait for the final publication of every standard, before taking action. Okay, we basically, compliance is very important. We know that if we don't fulfill, like let's say the AI Act requirements, providers, deployers, etc., will get penalized for that. We know that it's legally binding, etc. But like beyond that, I think we need to think about, so it's more as an entrepreneur, we need to find a great opportunity for product on the sales. Okay, basically, with this, let's say, with this AI Act regulation, we can really, I think, build better products. We know there are some very important guidelines regarding documentation, transparency, accuracy, test, cybersecurity, etc. So I think, it can lead us for great commercial opportunities, for better relationships with our customers, to help our customers also understand better, what's behind the hood, okay, or under the hood, because, they want a system that works, but like when you go into details, it's like way more complex than that, and it also helps them, to improve their competency and help us work together. So I think, that would be the first advice. Be interested into the standard, because it's not only, it's not. Let's say a bureaucratic burden, it's really an opportunity to deliver better products and I think, especially in the context of AI, it really provides like a great framework, for better product adoption. And after, it's there are also like some rules that are I think very important to keep in mind. Like, we talked about defining the intended purpose very precisely, because, systems are complex, operating domains are complex, etc. So really master the environment in which the system will evolve. It's very, very important. It's also important to keep in mind that with AI, systems, they are not static. They are live systems. They keep improving with data. They may shift as well, So basically, to be able to, let's say, to think about the evaluation strategy before finalizing the model, but, at the different stages of the design on the post-market monitoring, it's also very important, and very important also to let's say evaluate the systems under different conditions, and maybe the last word would be to engage with the standards early, like basically you mentioned that our standard is under public inquiry. That's also a good way to provide feedback on good ideas, to people like us who edit this standard. So basically, that can be the last advice, really, to get interested and to contribute also to these standards.
Well, that is excellent advice on which to end. And Nicolas, I'd like to thank you so much for sharing your valuable insights today. I'd like to also thank my co-host, Adam Leon Smith, but most of all, to all of you listening to the show. So please join us next time when we cover the full stack of IT standards, ethics, and regulation, and maybe get a bit of computer vision into it all. Thank you very much, Nicolas.